Okay, hello everyone. Let's look at number 13 question of the 2011 May-June waec past question, physics. Okay, this one says explain mutual inductance. Mutual inductance is a phenomenon whereby the change in current in one coil, okay, or alternating current passing through one coil induces EMF on another coil. Okay, so that's very important about mutual induction. The next one says state four uses of electromagnet. Okay, one of them can be electric motors. We use electromagnet to produce electric motors. And secondly is headphones and speakers. We use it in headphones, okay, and speakers. Okay. Thirdly is what we call electric bell. Electric bell also uses this principle of electromagnetic. Then fourthly is to we say I will call it crane pickup. Okay, that means to pick up large chunk of metals from one point to another. Okay, that's very important. Now the next question says the diagram above illustrates two coils X and are arranged. Okay, it should be X and Y arranged so that the axes are collinear, so they must be arranged collinearly. X is connected to an AC supply and has an ammeter in series. That should be an ammeter in series with it, while Y is connected to a lamp. That's the lamp L. Explain the following observation. I. The lamp is lit when AC supply is switched on. Yeah, that is quite easy. When the AC supply is switched on, okay, alternating current means that the direction of the current is not consistent. It keeps changing direction. Okay, that change in direction of current changes magnetic flux, and change in magnetic flux induces EMF on the other coil. And so the EMF induced in this coil means that current can now flow through the second coil, lightening the amp. So don't forget that AC current causes a change in magnetic flux, because change in current causes a change in magnetic flux, and change in magnetic flux induces EMF on the other coil, because EMF is actually induced whenever magnetic flux changes. Okay, now the second one says the brightness of the light from the lamp increase when the distance between X and Y is decreased. Now the reason is because the smaller the distance, the closer they are, the smaller the distance, the larger the inductance, the mutual inductance. Okay, and the larger the inductance, it means the more the EMF that is being induced. Okay, that is important for you to note there. Then that's why you see that the light becomes brightened when they come together. Now the third one says filament of the lamp glows brighter when bundles of insulation, okay, insulation iron wires, that's a mistake, is placed along common axis of the coil. Okay, when you place wire along common axis of the coil is another way of increasing the mutual inductance. Okay, it helps energy transfer easily. It helps magnetism or magnetic flux transfer easily from X to Y. That's very important for you to note. Okay, and yeah, so increase in mutual inductance means that more EMF, or will I say larger inductance means that more EMF is induced, meaning larger current would flow. Okay, so that leads us to the next one, the D part. It says two cells, one have an EMF of 2.0 volts and internal resistance of 0.4, and the other having an EMF of 2.0 volts and internal resistance of 0.1 ohms are connected in parallel. Oh, amazing. This combination is now connected in series with a resistor. Draw the circuit diagram of this arrangement. Okay, quite easy. You have two EMFs like this. This is a cell and this is another cell. Okay, the first one has EMF 2.0 volts and the internal resistance is 0.4 ohms. This one also is 2.0 volts and internal resistance is 0.1 ohms. I need to confirm that. Yeah, 0.4 and 0.1, correct. And the both of them are connected in the both of them are connected in series with a resistor. So this is the external resistor R. This is exactly what we have here. Okay, and the question now says, okay, calculate the current through the 5 ohm resistor. Okay, so that means the resistor is 5 ohms, so we can come here and say that this resistor is equal to 5 ohms. Now this diagram is correct, or you can also do it this way, since they say in series, but it's the same thing. Okay, so you can have something like this here, and this is 2 volts 0.4 ohms, this is 2 volts 0.4 ohms, and this is R equal to 5 ohms. Now the question actually says we should calculate the current through the 5 ohms. For us to know the current, whenever you have an EMF, current is equal to E over R plus R. This big R is the external resistor, which is 5, the small r is the internal resistance, and E is the EMF. Now, but from this combination, the total EMF, since they are in parallel and they have the same value, the total EMF is, just to pick one of them, is 2.0 volts. So the total EMF of cells that are in parallel, okay, is equal to one of them, as long as they are equal, as long as they have the same value. Okay, now but the for the internal resistance, they are in parallel, so I will apply parallel connection. 0.4 times 0.1 all over 0.4 plus 0.1, right? This would give us this is giving us 0.04 divided by 0.5, and divided by 0.5 means 0.08 ohms. Okay, now this is one way you can do this, or you can just say 1 over R equal to 1 over R1 plus 1 over R2. This is also correct, which is 1 over 0.4 plus 1 over 0.1. The LCM is 0.4. 0.4 divided 0.4 is 1. 1 times 1 is 1. Plus 0.4 divided 0.1 is 4. 4 times 1 is 4. So 1 over R will be equal to 1 plus 4 is 5 over 0.4, right? So that means R now will be 0.4 divided by 5, which is 0.08 ohms. So whichever way you can use, but I prefer using this. It gets my answer very fast. Okay, when two resistors are in parallel, you can just say their product all over their sum, and you get the answer. So now getting the current becomes very easy, because your current, the EMF is 2 now, the total EMF, the external resistor is 5, and the internal resistance is 0.08. So this is going to be 2 divided by 5.08. Okay, and let me use my calculator here. So we have 2 divided by 5.08. That will be 0.39. Okay, so 0.39. So we are going to come here and write the answer. So this is equal to 0.39 amperes. That's the answer to that question. Okay, that's quite easy. I think that is all for number 13. Okay, so see you in the next video for the next number. Thank you.